Welcome to This Explainer. Okay, I am absolutely thrilled you're here because today we are talking about a technology that honestly feels a bit more like science fiction than everyday manufacturing. When you look at a plasma cutter, you shouldn't just see a cutting tool, right? You are literally looking at a harnessed force of nature. It's basically lightning on demand, a localized star brought right down to your shop floor to slice through solid steel with just incredible speed and precision. But as any seasoned procurement professional or fabricator out there knows, taming that kind of wild power requires a whole lot more than just plugging the machine in and hitting start. The choices you make before the machine even arrives on the dock are absolutely crucial. They dictate everything from worker productivity to your insurance liabilities, and of course, your long-term uptime. So, how exactly do we safely harness all this raw energy?
Well, let's look at our roadmap. We're going to move spatially outward from the torch to the whole shop floor. We'll hit 1. Taming the plasma arc. 2. Breathing easy with air quality. 3. Stopping sparks for fire prevention. 4. Electrical and shock hazards. And finally, 5. Sourcing a safe ecosystem. Let's get to it.
Section 1. Taming the plasma arc. Radiation and noise. We're starting right at the tip of the torch, dealing with those immediate, visceral threats an operator faces on the floor.
To really wrap our heads around the hazards, we have to understand what the plasma arc actually is. It's a high-velocity jet of ionized gas, operating at absolute extremes of temperature. And because of that immense energy, it acts almost like an artificial sun. It pumps out an incredibly intense amount of invisible electromagnetic radiation across multiple spectrums, specifically ultraviolet and infrared light. If operators are exposed to this, they can suffer from welder's flash. Think of it exactly like a severe sunburn, except you get it indoors, in just a matter of minutes, on literally any exposed skin, like a neck or a wrist. This is why specialized flame-resistant clothing isn't just a nice-to-have suggestion, it is a completely vital shield.
And that right there brilliantly captures the most acute, real-world danger of all that radiation. Staring at the plasma arc with a naked eye causes photokeratitis, widely known in the industry as arc eye. Victims consistently describe the feeling as having hot sand permanently trapped right under their eyelids. It's awful and can actually lead to permanent retinal damage. So, to combat this, procurement teams have got to ensure helmets have a variable shade range. For plasma cutting, operators absolutely require a shade of 5 to 9 protection, depending on the amperage of the machine.
But wait, the light isn't the only assault on the senses. The plasma process is inherently, violently loud. Because that ionized gas is blasting out of the nozzle at supersonic speeds, it creates this high-pitched, tearing noise that consistently blows right past 100 decibels. Prolonged exposure to 100 decibels causes permanent hearing loss. Therefore, sourcing high-quality, noise-canceling ear protection, the kind that blocks out harmful high-frequency cutting noise while still letting operators hear verbal communication, that is a mandatory quality-of-life metric for your workforce. No skipping that.
All of this dictates a complete physical armor for operators. We're talking ANSI-rated welding helmets for the UV and IR light, grade A leather gloves with Kevlar stitching for that insane heat, split cowhide aprons, and steel-toe boots with metatarsal guards for heavy plate handling. But here's the critical takeaway, especially for bulk buyers. You absolutely cannot rely on generic, consumer-grade marketplaces for this gear. It is crucial to source this personal protective equipment in bulk directly from specialized manufacturers, and you've got to demand certified batch reports. You need to know for sure that the leather thickness and lens shade accuracy meet strict industrial benchmarks before your workers ever put them on.
Moving to Section 2, Breathing Easy, Air Quality. Zooming out from the operator's physical body, we run into the invisible, environmental threat floating right in the air around them.
When you slice through metal with plasma, that metal doesn't just magically disappear, right? It vaporizes. And this creates a dense, toxic fume cloud made up of ultrafine metallic dust, ozone, and nitrogen oxides. Now, the real-world danger here depends entirely on what exactly you're cutting. If you're slicing into galvanized steel, stainless steel, which contains highly toxic hexavalent chromium, or maybe older lead-painted metals, that ambient cloud becomes incredibly hazardous. A stand-in warehouse fan? Yeah, that won't cut it. Localized, at-the-source fume extractors, or even supplied air respirators become absolutely critical to keep your people safe and your facility compliant with 2026 industrial regulations.
Now, there's a really fascinating engineering contrast in how we manage those fumes right at the machine level. Buyers generally have two main choices here: water tables or downdraft tables. Water tables are brilliant because they use a bed of water to naturally muffle that crazy 100 decibel noise we talked about earlier. And they trap about 95% of the metallic dust without needing expensive filters. Sounds great, right? However, if you cut aluminum on a water table, the reaction actually creates pockets of highly flammable hydrogen gas underneath the plate. That introduces a massive explosion risk. On the flip side, downdraft tables use high-powered fans to literally pull fumes down into HEPA filtration units. They give you a beautifully clean, dry environment with zero explosion risk, but they do demand a serious recurring budget for filter replacements. It's a vital trade-off you really have to weigh during procurement.
Up next, Section 3. Stopping sparks. Fire prevention. Panning out further to the wider facility now, we have to manage the physical byproduct of the cut, the constant flying stream of molten metal sparks we call dross.
I really want you to visualize this number. 35. That is 35 feet. Imagine a spark of molten metal shooting out from the torch and traveling the entire length of a school bus across your shop floor. And here's the real kicker. Even after flying all 35 feet, that piece of dross can stay hot enough to easily ignite a rag, a cardboard box, or a chemical spill long after the plasma cutter has been turned completely off. It's wild.
So, to combat this massive fire hazard, you have got to enforce a strict 35-foot clear buffer zone around the plasma table. I mean it. No solvent tanks, no oil drums, absolutely no wood storage within that radius. Second thing, fine metallic dust is a combustion hazard all on its own. So your CNC machine needs a well-designed, easy-to-clean dross drawer or hopper to prevent dangerous buildup. And finally, extinguisher placement is key. If you are cutting combustible metals like magnesium or even certain aluminum alloys, a standard extinguisher simply won't work. You must mount specialized Class D fire extinguishers. For general steel, just make sure a standard ABC extinguisher is mounted within 10 feet of the operator, always.
Moving on to Section 4, electrical and shock hazards. Now we have to address the invisible force powering this whole operation, the massive electrical draw.
You see, plasma cutters operate using high-voltage DC, often pushing up to 400 volts. Because of this, proper grounding is probably the single most misunderstood safety tip in the entire industry. If a machine isn't grounded correctly, you create what's called a floating ground. This is a highly, highly dangerous condition where that massive amount of electricity actively seeks out the easiest path back to Earth. Sometimes, unfortunately, that path is straight through your expensive CNC electronics board, which destroys it instantly. Worse, that path could be through the operator. So the absolute crucial point here is that a ground clamp must be attached directly to the metal being cut, or to the table slots with a clean metal-to-metal connection. No paint, no rust, just pure connectivity to prevent a catastrophic floating ground.
But, voltage isn't the only electrical issue. There's also frequency. A lot of older or cheaper plasma cutters use a high-frequency, or HF, spark to basically jump the gap and start the plasma arc. This creates massive electromagnetic interference, or EMI. It acts almost like a localized EMP wave. If your facility uses sensitive CNC robotics, factory Wi-Fi, or, importantly, if an employee has a pacemaker, ECHEC starts are a massive liability. Sourcing blowback start torches, which use a pneumatic, moving electrode mechanism to start the arc instead, completely eliminates this high-frequency interference. It is a really critical safety upgrade for any digitally integrated modern factory.
Finally, Section 5, sourcing a safe ecosystem. Let's tie all of this together. Because a genuinely safe shop floor, it doesn't happen by accident. It actually happens right in the procurement office. Let's look at how smart sourcing can proactively filter out these intense hazards before they even arrive. When you issue a request for quote, or RFQ, your safety demands have got to be front and center. You must look for a few critical benchmarks. First, insist on valid UL, CE, or CSA marks for the entire assembly, not just one single part. Ensure there are multiple physical emergency stop buttons distributed all around the machine. Look for parts-in-place safety interlocks. These are super clever sensors that completely prevent that 400-volt arc from firing if the torch consumables happen to be disassembled, which directly protects operators from accidental electrocution. And lastly, demand IP54-rated electronics enclosures so that the highly conductive airborne metallic dust we were talking about earlier doesn't get inside the cabinet and cause a nasty short circuit. By prioritizing these specific benchmarks, you effectively filter out those low-quality, hobbyist machines that pose really serious industrial risks. And that really brings us to our final thought.
Whether you're setting up a smaller private label shop or outfitting a massive manufacturing conglomerate, the main question remains the same. Are you just trying to buy a tool that cuts metal, or are you truly investing in a hazard-free ecosystem? Listen, industrial safety is never just some optional add-on. It is literally the very foundation that keeps your business running, and most importantly, your people safe. So, as you look at your next equipment purchase, ask yourself, how are you going to use these strategies to preserve the true value and the safety of your investment? All right, thanks so much for joining me on this explainer, and I'll catch you on the next one.